to tutorial number 1 of 2021. So this is going to be, I hope, a fast one, but this tutorial is all about me trying to push as much as possible from my laptop, right? And a little bit of backstory, my laptop has 16 gigabytes of RAM, so I am constantly limited by how much I can render and how much of a geometry I can work with, right? And me being an architect, I constantly kind of make, let's say, these kind of panels or anything a little bit more complex that has a lot of mesh faces or a lot of surfaces, if it's a poly surface. And I need to create interior spaces, create exterior architectural cladding, and so on that has a lot of, like, let's say, multiplications of this kind of geometry, right? If I were to kind of show you the geometry right now, let me bake it out really fast. There we go. You'll see that this guy right here has a lot of polygons, right? To work. I could remesh it and I could end up with a little bit less polygons, but it still would be a lot, right? So even if I kind of copy it, or not even if, but if I copy it even into a grid of 2 by 2, now what I'm dealing with is around a million polygons here. So you can see how it becomes an issue quite fast in terms of RAM. So I was wondering how to actually use this, right? How to use this for rendering and so on when you have a shitty laptop, just like I do. Well, first of all, there are like 3 levels of complexity that you can deal with, or 3 levels of representation that you can deal with. First one is geometry based, right? So this guy right here is just a quick definition. I'll show it on the screen real fast here. Make a print screen if you want to copy it. But basically what it does, it just creates wood carving simulation, right? As if a piece of material was carved out with a chisel, right? A piece of wood block was carved out with a chisel to achieve this kind of effect, right? By the way, the definition itself, like this portion of the definition, will be available for the Patreons. Well, maybe not even this one, more than that, the whole definition. So, if you support the channel, you get this kind of crap for free. If you don't support the channel, follow along, right? And we will have some fun. So let's begin. 3 levels of complexity. Level 1, geometry, right? Either a mesh or a poly surface. That requires the most amount of RAM, the most amount of computation power, and so on when you're dealing with that geometry. Level 2 would be using a displacement map, right? So some sort of white and black map that would take a piece of flat geometry and would displace it in the render engine to create 3-dimensionality. And level 3, which is the lowest one, would be bump maps or normal maps. And this is where we're going to kind of be heading towards. So the difference between normal maps and bump maps, No, I will not be getting into those. If you don't know what a normal map is, stick around. I'll kind of explain it throughout the overall tutorial. So first of all, I want to go from level 1 to level 2, right? From solid geometry into a displacement map. So I want to generate a displacement map from this. And the way displacement maps works is basically it has, it's a bitmap first of all, so it's a texture, and it has pixels, right? So each pixel corresponds to white or black, or the gradient in between white and black. And the brighter a pixel is, the higher it's going to be pushed up. The darker the pixel is, the more it's going to be pushed down, or rather not move in this regard. So how do we recolor this so that faces that are high up are white and faces that are being pushed down are black? Well, to do that, we need to well, first of all, delete the preview and just look at the mesh. We need to get the vertex information from the mesh, and that is done by using deconstruct mesh component. Deconstruct mesh, like that. So this gives me all of the vertices, all of the face information, all of the color information, and all the normal information of the mesh. Let me hide that, just a second. There we go. So now in terms of actually coloring this, this form, I will be using what's called a mesh color component. Yep, can't find it here, so I'll just go to the mesh tab, go to primitive, and here it says mesh colors. So I'll be going for that, mesh colors. Okay, the mesh that we're going to be coloring is going to be coming out, it's just the mesh that you're coloring, the same one that you're deconstructing. I'll be doing that. And the color information, well, why is it not showing up? That's weird. Oh, never mind, it is. So once you do this, it's going to color the mesh in a very funky way. Don't worry about it for now. That's because we haven't set any color information for it, so it's using a default value of, let's just call it the default value of weird. So I need to give it some sort of a gradient, right, to color this mesh properly. So I'll give it one gradient, like that. And my gradient, if I right-click on it and go to preset, is going to be coming from black to white, right? So the closest one that I see is here, from white to black, but that's easy enough to fix. I just switch it around like so. Now it's coming from black to white, and I'll just connect it to the color input here. For the gradient to work, it needs to sample a bunch of parameters on this gradient, right? And it has 3 inputs. The first one is, okay, so what's the lowest limit? The second one, what's the upper limit? So basically, what kind of parameter corresponds to this point? What kind of parameter corresponds to this point? And the last one is, give me all of the parameters in between, any number that we ask of it. So, I can give you a quick example as well. Let's say our lowest number is 25, right? Our largest number is 155. I don't know. I'm just kind of guessing, not guessing numbers, but inventing numbers here. And my parameter is going to be between 25 ... 155. So a slider between those two, right? If I now connect my slider to this with number of 49, it's going to give me this gray color. But what I can do is I can kind of move the slider around, and it's basically sampling in between 25 and 155 and finding the correct color that would correspond to the parameter, like this. Okay, so that's how it works. For us to actually color the mesh according to, let's say, how high each vertex is, we need to first understand how high each vertex is, right? So I need to deconstruct the points, the vertices, right? So point deconstruct, and I get the z coordinates, right? Okay, that's great. That's going to be, the z coordinates are going to be our parameters. Well, maybe later. I'll connect them later. But those are going to be our parameters. Also, I need to know what is the smallest and the largest value that we have, right? So for that, I will use bounds component. I'll connect z to bounds, and I will deconstruct that component. Deconstruct domain. Not squared, just regular deconstruct domain. And it's going to give me 2 numbers. So basically how this works is, if you have a list of numbers, right? So here in the z, I have a crap ton of numbers. Okay, there's a lot. There's like 258,000 numbers. The bounds will find the smallest and the largest one, right? And then when I can deconstruct that bound, I have those numbers, the smallest and the largest number, I have them in separate outputs, which means I can straight up connect them, start and end, to L0 and L1, just like that. And then for t, as I mentioned before, I'll be using the numbers in between those brackets, right? So all of the z coordinates. and my mesh gets colored, right? But the problem is that gradient starts from the bottom of the panel, and I actually, the most interesting thing for me is, the waves here. So I need to actually do this. Bring it in and find a good value at which we will have like a nice gradient. While I'm talking, let me turn on Photoshop, because I will need some sort of it's not necessarily Photoshop, but some sort of a program to be able to crop an image. So I'll be using Photoshop for that in my case. And that's basically it, right? So what we have here is this mesh gets colored, and we have our white and black color information, which we can use as a displacement map. So I'll go to the top view and I'll take a look at it. So this is how it looks. Let me just hide this curve here so that it's not in the way. And that is indeed our displacement map. So I need to get it as an image, right, to be able to use it as a displacement map. So I will type in Rhino, by the way, in Rhino, I will type in view capture to file, and I'll say, sure, 1920 by 1080, that's my resolution, but scale it twice, right? Scale it 2 times. This is how it's going to look like. It doesn't matter. The gray part doesn't matter, but this is basically how it's going to look like. I hit OK. I'll just save it to the desktop as tutorial displacement. Hit save. And it just gets saved, right? So now in Photoshop, rather, let me just jump real quickly into the desktop and find it, and I can see it. Let me refresh. Now I can see it. I'll just drag and drop it into Photoshop to open it up. This is it, right? I'll hit escape a bunch of times so that it doesn't get cropped. I will use the magic wand tool with tolerance of 32. That's fine. Nope, that's not fine. Tolerance of 5, let's say. Yeah, that's good. So I select everything except for the bitmap. I'll go to select, inverse. So now I select only the displacement map portion of it. I'll Control X to cut. I'll go to File, New, choose that it kind of cuts from clipboard, create, Control V, and that is going to be my displacement map. And I can kind of see that there is some shit on the corners here, which I need to take care of. Like those small white lines. I'm not sure if you can see them, but let me just, yeah, there we go. So that edge right there, that's only 1 pixel. So I can just go to image, canvas size, and here just change the, like remove, let's say 2 pixels, right? 1945. I'm just removing 2 pixels, proceed. Now it should be a bit better. Yeah, that's good enough, sure, whatever. So this is what we end up with. This is our map, and I'll just Control L, which is basically, what is Control L? Levels. And I'll just change the levels, just increase the contrast just a tiny bit, so that more pixels are dark. Control Alt S and save it as tutorial displacement. I'll just overwrite it. Yes, replace it. Could not save because the document. Oh yeah, I need to close this one and then do this again. Control save, tutorial displacement, save. Yes. Okay. So that's it. That is right now done. Let me turn on this, turn on that. There we go. So now I have that image, right? So for now, let me just hide this or disable this, right, completely, so that it doesn't get calculated. And I'll be moving into creating a normal map. So the first thing is, well, actually, let me show you how that's gonna work, right? Because that's kind of cool. Let me show. That's the curve that I've used before, so I'll just be reusing it. I'll just create planar surface on it. So that's a surface. Let me go to V-Ray, create a material, Actually, I'll just borrow a material. Hopefully it's going to give me like a plywood material or something like that. Oh my god, come on, please. Please. Checking for updated library. Yeah, there we go. Wood. Sure, maquette wood, that looks fine. I think we'll see if it's actually fine. Can we use it? How do you look like? Yeah, you're fine. You're fine. Okay, I'll just use, or no, that's kind of boring. Let me delete that. Instead, I'll use plywood. Sure. You, please, sir, come in here. There we go. That's our plywood material, and I'll just apply it to selection, and I'll just render out a quick test render. Right, so this is how it looks like. Nothing fancy, really nothing fancy. Just a piece of wood, right? So now I want to displace it, right, with the new displacement map that I've made. Let me stop the rendering. So I will go into add attribute, and I'll add displacement attribute to it, to the plywood material. I'll turn it on and choose a bitmap, and I will precisely choose tutorial displacement bitmap here, like that. Right? So that is done. And now I can change the amount of it. So for the amount, this is like 1 millimeter. I'll just say 3 centimeters. Let's try that. I will click render again. And now you can see that the panel has been displaced, right? So I have the same texture that I had before, only that now I have it not as geometry, but rather as a single bitmap, and it gets displaced here. The problem with that is if I check my task manager, it is still it's still pretty heavy, right? It's 10 megabytes or 10 gigabytes, sorry, of RAM that's being used. So I'm only have 6 left. If I was rendering out the whole interior, this wouldn't work. Well, I would need more RAM for it. So that's a problem. That's an issue. So this is where we can kind of jump back into Grasshopper. And instead of working with a displacement texture, we can convert it into a normal map texture, which is going to be much faster, but of course with certain amount of limitations. So let me do that. First, let me delete this. First, I will select that curve that I have. The curve is 1 by 1 meter, by the way, 1000 by 1000 millimeters. So I'll select that curve, and I will convert it into a surface. So I'll just use boundary surface tool. So now it's a surface, and that surface I'll divide. Or no, I will not even divide it. I'll just use mesh surface component here, and I'll divide it up into, let's say for now, let's just use 128 by 128 polygons, right? And you can't really see the polygon, so let me go to display, preview mesh edges, and now we can see all of the polygons here. This is not going to be enough, but this is going to be good for testing out, right? And I've hidden the boundary surface component as well. So we have our mesh, right, created, and I will deconstruct this mesh. Nope, that's the wrong one. Deconstruct mesh. I'll deconstruct this mesh into its components, so I have the vertices and the faces, and I will reconstruct it. So construct mesh. I'll construct the mesh. So I'll be using, if I were just doing this, vertex and faces go in like that, it just kind of rebuilds the same mesh for me. But the nice thing about it is that in between the vertex deconstruction and reconstruction, I can move the vertices around, right? So I will be moving these vertices along the z-axis according to the displacement map that I have just generated, right? So I will use wait, I'm thinking, just a second. How do we use this? I'll use an image sampler. Image sampler, right here. I'll right click on it. I'll choose image. And I'll find my displacement image here. So it gets loaded in. I'll right click. I will right click on it again. And I'll go to, is it wire display? No. Settings. I'll go to settings. And here for X and Y domain, I will choose what's the size of my rectangle. So I know for a fact that it's 0 to 1000 by 0 to 1000 because it starts from 0 and goes by 1000 in X and Y direction. I just hit OK. This still complains. That's because we're not sampling anything from this image. So to sample something from this image, all I need to do now is just connect the vertices to this. And now it kind of finds a color for them, and it spits out a value for us, right? And that value is in RGB values. I don't want that. I want just the brightness value for this. So I'll go back to settings here. And here where it says channel, I'll just choose the last one, color brightness, this channel right here. I'll hit OK. And now it's values between 0 and 1, right? So that's great. And I'll just connect it to the Z component here. And the movement, I'll connect to the V component here. And that's basically, right now, these are being displaced and you can't really see it. That's because they are being displaced by 1 millimeter, right? That's because these values come out as being between 0 and 1, right? White meaning 1, 0 meaning black. If I were to multiply them, though, by, let's say, something stupid like 100, that would mean that the white vertices become, white vertices get moved up, or white pixels move up the vertices by 100 millimeters, which is 10 centimeters, which is ridiculous. So let me reduce it. And let me just check real fast. Okay, so let me reduce it to 20, something like that. And I end up having this kind of a nice, nice texture here, right? So essentially what I did was I just used this displacement map in two ways, right? I used it in Grasshopper, and also I used it in V-Ray. But hey, you ask, is it possible to just kind of do it here instead of just generating the displacement map? Can we, could we just use the further steps on this mesh? And to that I will answer, well, you'll see. You'll see. Wait, you'll see. We do have this whole mesh displaced, and now it's kind of reduced as well. I could increase the complexity of it a little bit to 256 by 256, but for that I would need to turn off the preview mesh edges, just so that you can see better, and you can't. So I'll turn the mesh edges back on so that you can see better. Okay, back here. We need to create a normal map for this. So if I were to Google it for you, hey Google, what's a normal map? Those of you who have Androids will, yep. Those of you who have Androids will have Google popping up and saying what's a normal map. But those of you who don't, I can just really quickly show it to you rather than explain. It's basically a bump map with a little bit more fancy features that tell you about the orientation of each surface, right? So a normal map has, let's see this. a normal map is used to kind of create an illusion of a bump, right? So it's different from a displacement map because it's just an illusion. It doesn't actually change the geometry. So it only works with shading, right? So it only works with shadows, but not the geometry itself. It's a little bit complicated. But basically, what you have here is, where is it? There we go. That's actually a good example of it, right? So on the left-hand side, you have the displaced geometry, and on the right-hand side, you have the normal map of geometry. And you can see how the normal map can detect the shading and the lighting and so on, and it can mimic that, but it doesn't have three-dimensionality. If you're rendering something far away, right, relatively far away, then you don't need three-dimensionality. That's just an extra unnecessary shit that your computer has to deal with, right? So what you end up doing is just using a bump or a normal map. The bump map is not that great. The normal map is faster and better. Let's just stick to that theory, right? The question is how do we build one? And for that, I believe this is that. I don't remember which website it is. Blah 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 blah. Crazy bump. Photoshop in normals. No. You then you. This is keep in mind that somebody we can code the blue channel without the negative part. Effectively, okay, so that is also not that. Oh my god. Can I just do normal map? Normal map color chart, please. Please. Either way, in the normal map, the colors are RGB is locked into XYZ, right? So the more surface is facing towards towards north, the more red color it's gonna have, or no, sorry, the more surface is facing towards the east, the more red color is going to have. The more it's facing towards the west, the less red color is going to have. And same thing for green and blue channels as well, right? So the blue channel is facing upwards. So that's why you have this purple color most of the time. That's because your blue channel is kind of fully loaded. Like, so you have full on blue, and then you have 50% red, 50% green, right? That's why it's purple. Let's do that. That was a shitty explanation. I'm sorry for that, but read up if you don't know what a normal map is. Anyway, let's do that. So what I'm going to do is I'll just say, okay, do we deconstruct? Let's deconstruct. Do we deconstruct? I will deconstruct. Deconstruct mesh. Right? I will take this mesh and I will deconstruct it. And I have the face normals. Is it the face normals or vertex normals? We'll see. 66,000. Okay, I have the vertex normals of the mesh. So I will color the mesh as well, right? Just like we did it here, right? I will use mesh color. Mesh colors. And this mesh will be colored with with colors corresponding to X, Y, Z values, right? So again, let me scribble it for you. X equals red y equals green, z equals blue. That's not an equal sign, I know. Shut up. Red, green, blue, right? So I have these vectors here, and they kind of have alignment towards x, towards y, and towards z. So I need to deconstruct them. Deconstruct. I just need to deconstruct them, right? And then I need to ask, or not ask, but rather remap the values of x. And by the way, when you're dealing with normals, the values are always between -1 and 1, right? With 0 being 0, right? So if vector is looking backwards, it's -1. If vector is looking forward, it's 1, right? So what I'm going to do is I'll say, okay, for x, if my source domain is between -1 until 1, something like that, and my target domain is between 0 and 255, that's because RGB values work with 255, I will end up having my values mapped to along the x direction, right? Oh, the red value. So here I'm just kind of constructing the red values. Then I will just be kind of quick about this. Or rather, can I just do... Sorry. No, I can't probably. Never mind. I'll do the same thing with y and the z, right? So red, green, blue. The output here is going to be red, green, blue, because I'm remapping from vectors to colors. And what if I just join them? Or can I color RGB? Can I just do this? Let's see if it's going to be heavy or not. Oops. That is not what you want to do. It is pretty heavy. It's 2.2 seconds, but I think that's something that we'll need to deal with. Or maybe we can kind of cheat a bit. And what if we graphed, merge, so that these guys get merged in being 3 numbers for each data branch, like that. So now what I have here, if I check it with a panel, is 3 numbers, then the next branch starts, 3 numbers again, the next branch starts, and so on. And I join, or rather, I need to run it through integer at some point. Integer. I run it through the integer tool here to force it to be full numbers, right? Without any digits after the comma. And then I can join text. Oh, maybe that's not gonna work. Oh no, it's not complaining. Okay, cool. Join text with a comma. So that's a comma between each line. So what I end up having is this, right? Which is basically a freaking color information, right? I will just flatten this out into one single list. Make sure that you do that. I'll just connect it to the color information here. And if I hide everything so that nothing is in the way, this is how it's gonna look like. Let me disable preview mesh edges. This is how it's gonna look like, and that's exactly what a freaking normal map is, right? Things that are looking towards the right are a little bit more red. Things that are looking towards the Yeah, and things that would be looking towards the bottom or the south are they should be a little bit more green. No, towards up. They're more green if they're looking up. So you get that cyan color there. Let's see if we can simplify this, because I have a theory that if I were just to remap the vectors, are you gonna work? Don't get grafted. Sorry, I'm just looking at it real fast. No, it's not gonna work. Okay, fine. So we do it this way then, right? So we have our normal map. Yay! We have our normal map, right? Then I can just straight up go to my view here, hide this, view capture to file, okay, tutorial normal, hit save, go to the Photoshops, drag this tutorial normal here, open it up, and do exactly the same procedure. Select inverse, Control X, file, new, create, Control V. There's a lot of crap here, so I will probably just use a cropping tool and zoom in quite drastically to this. Like that. Let's go up, fix that part. I don't really like that gradient here, so I will be fixing it a bit. Like that. Then here it is kind of okay. No, it's not okay. So this side, move it in. Once you get the hang of it, it's kind of fast. And this just goes until here. Okay, so that's my cropping. I just hit enter. Control, wait, no, close that. Control Alt S or Alt Control S, override tutorial normal, save, yes. Hit OK. Now it's overwritten, and now I can use this as a normal map. So let me show you real quick. In Rhino, let's render this out. Just a second, my phone is going crazy. Why are you going crazy? So rendering. Let me jump into here. Let me actually create a quick box. Yeah, why not? Scale or scale 1D. Let's say 30 millimeters. Let's say this is my panel, right? And up until now, I have this plywood material applied to it. And if I render it, it's going to look like this. And it's not going to be the best, especially considering the edges. But it is what it is, right? It kind of works, right? It is indeed displaced, at least. So let me stop rendering that and instead make a bunch of copies of it. Or maybe not even copies. Maybe I can just kind of do this. Like that. That's good enough, right? So this is my large surface here. Let me delete this plywood material, and I'll just create a new one. And for this one, let me just create a very simple one, generic material with a little bit of, let's see, it's a bit darker, but it does have reflection on, right? Wait, that's refraction. My bad. Reflection on and 0.8 glossiness, something like that. So I have this kind of material here, And I can go to the bump map and choose that I'm going to be using normal map. And here I can choose a bitmap and I can find my tutorial normal. Hit open. Hello? Bitmap. Oh, okay, it did it. Okay, so now we have our normal map here. And if I apply this material and click the render button, the almighty render button, I can see my normal map being placed here. The size of it is shitty, so what I can do is, this is a meter, by the way. This guy here is a meter by a meter, so what I'm going to say is texture mapping, UVW repetitions. No, I just want a box map. Enter, enter, enter. You just wrap it in the box mapping. And XYZ size, I'll just choose 1000. Come on. 1000 by 1000 by 1000. Okay. So we have something like this. I can see that I messed up the seam, but if I zoom into this and kind of look at it at an angle and wait for it to render out, I can see that that texture that I wanted to create is actually being created, right? But the thing is that this is super lightweight. This doesn't cost almost any RAM because it's not three-dimensional. So, but also, since this is going to be used far away from the camera, I don't care, right? One thing is the tiling. So in case of the tiling, I would probably want to crop in a little bit closer and also to make this a little bit more seamless and whatnot. I can do that in Photoshop. Let me stop that. I can do that in Photoshop by just really quickly image canvas size, saying, let's say 4000 by 4000. I'll just do that real quick. Up, don't do that. Move this here. The back color doesn't matter. Make 2 copies of this. Move one of those. Up, I said one of those, not both of them. One of those to the side here. Right click or Control T. Right click. Flip horizontal. So we end up with this kind of weird thing here. Which I probably want to fix. Do I want to now kind of start fixing the texture? I don't. So I'll just click no. I don't want to start fixing the texture. This is a tutorial about how to do it, not how to make it pretty later on. One thing that I can show you though is pretty neat. So in that bitmap texture, which I have here, right, the normal map texture, if I go to texture placement and go to, or rather choose type to be mapping source and click on UV placement source right here, UVW placement. Here I can go to randomization and I can say that it needs to use stochastic tiling, right? Which will kind of mess it up like so. But I believe if I UV rotation, if I change this to like 15 degrees, it already kind of starts breaking up the tiling. And also I can change the scale to 120, between 80 and 120, and so on. So you can mess around with this, minus 15 to 15. You can mess around with this. That's too much. Minus 5 to 5. And maybe increase the blending a bit. And get rid of, in this way, you can get rid of the tiling, right? So that's how you do it, right? And that's how you kind of get rid of how you generate a normal map and get rid of the unnecessary RAM usage if you have a crappy computer. Now, that definition that I've showed you, this guy right here, can we use it on this mesh right here? Of course we can, right? So let me enable this real fast. And let's just wait for it to load up because it's a chunky boy. That's the actual reason why we are using freaking normal maps and displacement maps and whatnot to visualize it. So it got loaded in, and this is the part which generates a displacement map, and this is the part from here, from the construct mesh, which generates the normal map. So let's see if that's gonna work for us. I will just copy it in like so, or not copy it in, but plug it in like so, and wait. And we'll just see. We will just see. I probably should have saved. Now when I think about it, I probably should have saved. Time to stop the video. Actually, it kind of calculated right once I've just closed the closed the video, right? So it's not that bad. Let's take a look at it. Hi, Dad. Look at this. Absolutely the same thing. The only difference is that here we have some dots and points and so on, but it is absolutely the same kind of map, right? And we can do exactly the same thing with it, and generate the material, not material, what am I saying? Generate the normal map from here as well. So there's like a bunch of different things that you can do. For instance, if you already have a displacement map, but you want to generate a normal map from it, you can use this, right? And generate it that way. Wait, am I? Oh, I'm stupid. Wrong. I did it wrong. Instead, it's only this portion that we need to do. Because right now I'm taking this shape and I'm displacing it with the displacement map again, and then kind of coloring it. So it's like a double trouble. I don't want that. So I just need to create a mesh. That's stupid of me. Create a mesh component here. Actually, let's do it this way. Let me grab all of this, disconnect that, connect this, so that it kind of calculates the 256 by 256 texture for us. That's done. Come back here. And then I can actually just borrow just the last part, this part from here, copy paste. Now it's gonna kind of calculate again. I should have disabled this. Sorry. Bear with me. Drag it here. Now disable. Connect. There we go. And it's just going to color the, color this thing. Actually, I can show you why not? While I have you here, while I have your attention, please stay. Please press the like button, subscribe, donate money to the channel, please. Please. Maybe it has something to do with the fact that I'm also recording the video that it doesn't like. Oh, never mind, it did it, right? So now we have two versions of it, two variations of it, and I can kind of, let me just move one of them by X, nope, unit X by 1000. Bam, like that. So this one is here, right? Hmm. I'm just looking at how much smoother this one is compared to this one. This one is super aggressive, while this one is super smooth. But if I zoom in, you can see the difference, right? So you can see that the bottom one, the one where I used the displacement map and then mapped it, is a little bit more blurry, and this one is a little bit sharper. And that the reason for that is simply because here I'm using 256 points, 256 by 256, while here I have more, right? Just much more. I can make this better by doing 512 by 512. It's just that it's going to also take a little bit of time. But you know, once you build up your library of your normal maps, your displacement maps, and so on, of your own designs from your panels, you will not need to do this again. So it's just you know, a little bit of time spent doing this, and then just kind of having it right straight up. So let's wait for this to crash. Or no, I mean not crash, succeed. There we go. So now this is much sharper, right? Quite useful. All right. That's that. That is it. That's all that I wanted to show. Again, this whole definition, including the carving part, you will need Dendro for the carving part, by the way. Including the carving part will be available for the Patreon supporters. So if you are one, check out the Patreon page and just get it for, you know, get it without spending any time on it. For the rest of you, follow along, invent your own mesh, create your own mesh design, and just do it. Cool. Okay, I'm off. See you guys next time. Bye.